Hello, gamers. This is your captain speaking, and we're going to be looking at a new game in this video. The name is kind of an interesting name. It's MHRD, and it's a game on Steam. Available on Steam right now, and it's really a different kind of game, and you're looking at it right now. This is a game where you come up in one of the old type of computer, and you use this computer for engineering logic circuits. And there are other games that are similar to this, and some that I've played, but this one looks like a really interesting one. I'm just getting started in it at this time. There are a few things that I had a little bit of trouble right at first getting used to, and we'll mention those just in case you find the same problem. But when you come up into the game, it looks a little bit like this. Some of this is a little bit different because I've played it some already. Normally these folders on the left are already expanded. I'll just go ahead and expand them so you can see what they look like. You can see what the you can hear some of the sound effects that the game has. It sounds like an old computer with a rusty fan, and every time you click a button, it's a very, very loud click, like a really, really, really old keyboard. So it's kind of interesting. I'm going to go in here, and first thing we'll do is look at the settings, and in the settings you have ability to control the sound, the color, the display, and then you can reset everything to its default settings from this point. Now, I had a little trouble getting over to the right hand side of the screen. I wasn't really familiar with the nomenclature at first, but then finally found down here at the bottom left under quick help, it said activate the workspace, press enter. And so if you press enter at this point, the cursor, this is a cursor that is highlighted options now. The cursor highlights the options that you're working on. It looks like options is highlighted and on is highlighted for sound. So we're actually on the sound option right now. And we can switch tabs by clicking the tab key, or we can go back to the Explorer side of the screen by clicking the escape key that's on the very left. And I think you can change the sound by just using the arrow keys left and right. And so by clicking the sound off, we get rid of some of that annoying sound, at least for this video. Click down in color. There are 3 color modes. There is the off mode, where everything is white, and the mode 1 you have a green look, and mode 2 an amber look. Then down on the display you have the option between full screen, borderless, and I don't know what the difference between full screen and borderless is, and but you can go to window, and it just drops down to a window like that. So we'll just keep it on full screen. And then To reset everything, we can just press enter. We won't do that at this time. I'm going to click the tab to switch the tabs to statistics. And this tells us what our top score is so far. You can get a top score for friends and a top score for global. And I guess that is somehow tied into friends on, perhaps friends on the on Steam. I'm not sure exactly how that works. But then we'll hit escape to go back to settings. We'll come back up to documents and briefings and welcome. And that is where you first come into the program. And this basically is the beginning of the program. And at this point, you just need to read the instructions, read the text on the right-hand side of the screen to learn about the program, and then get down into the manual and look at the instructions for the game. The welcome screen just tells you a little bit about what you're going to do, and most of that is going to be repeated in the manual instructions. So I'm going to skip this for now. We're going to go on down into the introduction. And so here is the introduction. And to get all of the introduction, you need to press escape to get over into the introduction. Then you use arrow keys to scroll up and down in the introduction. The introduction tells you that the manual will tell you everything you need to know to start creating hardware elements. And this chapter will give you a rough overview of what you have to do. The other chapters will give you detailed information on specific topics. Also, the manual contains a tutorial you may find helpful. It tells us what our job is, tells us a little bit about the interface, tells us something about specifications here, and so on. Again, if you want to read that, you can just pause the screen, read through that. I'll let you pause and read, and then I'll scroll down to the bottom of the screen so you can get all the rest of the information. You can pause again and read the rest of that if you're interested. I'm going to go back into the Explorer, and we'll look at the tutorials. And here is the tutorial. This is where you learn how to run the program, run perform and do the objectives of the program. The description says this tutorial is meant to get you started with the MicroHard development environment. This tutorial has the exact same structure a normal hardware element has, except that it basically provides you with a working solution. In other words, normally the working solution will not be there. You just have the specification but not the design. What you are currently reading is the specification for the TUT1 hardware element. In this tutorial, we'll create a design for it which has the following behavior. The TUT1 element has two inputs and two outputs. The first output should output whatever value the second input has, and the second output should output the value of the first input. All right, that's pretty simple. Make sure you read the rest of this specification and head over to the Design tab. The interface specification says it has two inputs, N1, N2. It has two outputs, out1 and out2. Then we have a graphical representation where the inputs and the outputs are represented, but not how the internal works of the component works. This only gives us the inputs and the outputs. And then we have a example or a input and output table at the bottom that tells what the inputs are and what the outputs are expected to be. So If N1 and N2 are both 0, then out 1 and out 2 will be 0. If N1 is 0 and N2 is 1, then out 1 will be 1 and out 2 will be 0. Vice versa, if N1 is 1 and N2 is 0, then out 1 will be 0, out 2 will be 1. And then if N1 and N2 are 1, then both out 1 and out 2 will be 1. Pretty simple. Now we'll go over to the next tab by clicking tab, and we see the design. And here we see the design for this, and it kind of looks like a programming specification here, doesn't it? The comments are given in, are started with a double slash key, so you can comment the work that you're doing. It starts with the inputs, then the outputs, and then the wires, and then I guess that's all for this particular thing. You'll notice as I scroll through or with the cursor that every now and then autocomplete suggestions pop up, and that is based upon where you're at in the document, and you can autocomplete this thing some way. We'll learn how to do that as we're going through, but you have to specify your inputs first and then specify your outputs in the program. The inputs are N1, N2, and outputs out 1, out 2. That is given in the specification. And then you have a wiring specification. This program, this tutorial doesn't have any parts in it, so there's usually a parts section in here that you have to specify as well, but not in this case. So let's take a look at this instruction about the wiring. The specification says that the outputs have to have the same value as the inputs, but switched or reversed. This can be done by connecting N1 to out 2 and connecting N2 to out 1. If you drew this, it would look something like this. And so they show you a little graphical representation of this part. And then under wires, it says, however, you have to tell the simulator what to do according to the syntax specification. This means you would write in and then an arrow or a dash greater than symbol, out 2, then a comma, and then N2 pointing to out 1, and then a semicolon. If you'll notice, each of the sections in the design start with a label, inputs at the top, and then there's names or instructions, N1 separated by a comma, and then the inputs section ends with a semicolon, and that pattern goes all the way through this design. Output you see is the same. It starts with outputs colon, out 1, comma, out 2, semicolon, and then wires, where you specify where the wires, how the wires are connected. N1 connected to out 2, comma, N2 connected to out 1, semicolon. And so the syntax for wiring is basically start pin, arrow, end pin. And you can specify as many as wires as you want within your part, but you have to separate them by commas. And after the last wire, instead of a comma, you put the semicolon. And if you press Center Enter or Control Enter, this will tell you that this design passes verification. So we'll click the Control button and the Enter button, and we get a test is run, and it tells us that the verification passed. It tells us that this part has no NANDs, and there are 4 tests. We're N1, N2, or 0, 0, then 0, 1, then 1, 0, and 1, 1, just like we saw in the specification. And the outputs are as they are expected to be. And so you get the result on each of the tests where it is passed. You click OK there, and that completes tutorial number 1. I'll go back to Explorer again. Now let's look at a little bit more interesting tutorial. And in this tutorial, we're going to build a NAND gate using a NAND gate. And this is kind of a simple tutorial. It really doesn't do anything useful, but it gives you a little more information about what the design is within the program. He says usually this specification would explain what a NAND gate does. We're not going to do that. Well, they don't do that in this case. I'll let you know what a NAND gate is myself. A NAND gate has 2 inputs and 1 output, and it is the opposite of an AND gate. An AND gate, the output is 1 if both of the inputs are 1. If only one of the inputs is 1, or none of the inputs is 1, then the output of an AND gate is 0. So there'd be 1, 0, and 3. I mean 1 and 3 zeros for an AND gate if you had one. A NAND gate is just the opposite of that. An AND gate will produce 1, 0 output and 3 1 outputs. It is 0 if both of the inputs are 1, and it is 1 in any other case, whether it's the inputs are 0, 0, 0, 1, or 1, 0, then the output would be 1. That's what a NAND gate is all about. And so, but you don't really need to know that for this test, for this tutorial, because they're going to just make a really simple NAND gate using a NAND gate. And so we have here inputs, just like we did in the last tutorial, inputs colon N1 comma N2, outputs out, just one output from the NAND gate. Now, how do you build a NAND gate with a NAND gate? Well, you just put a NAND gate within the NAND gate. And so the parts is the next section. You have to name the part. In this case, the name is given as my NAND, and the part is a NAND. So the syntax is here is an ID that you specify yourself, and the part type, and the part type is always uppercase. In a real test, you would put as many parts as you needed to complete the specification or complete the test. Then you have the wires section. You have N1, and that the input for your part will be tied. N1 will be tied to my NAND.N1, and N2 will be tied to my NAND.N2. And my NAND.out will be tied to the out connection, then a semicolon. All these are separated by semicolons. So you can connect the elements pins to the pins of the NAND to make sure to reference the right part via its ID, and you declare it again. Control Enter to check the design if you want, so we'll click Control Enter. And now we see the verification passed. Notice the inputs and the outputs. The inputs 0, 0 produces a 1 output. The output 0, 1 produces a 1 output. 1, 0 produces a 1 output, and 1, 1 produces a 0 output. A NAND is a not AND. It's just the opposite of what an AND gate would give. If you know what an AND gate is, then a NAND gate is pretty easy to figure out. Interestingly, from a NAND gate, you can create every other type of logical circuit. Starting with just a NAND gate, you can create every other type of logical circuit. And that's what we're going to be doing here in this program. The first task in our task list is to produce a NOT gate. And we're going to have to create a NOT gate with a NAND gate. Use the NAND gate to create a NOT gate. A NOT gate is a really simple component. It has one input and one output, and the output is always the opposite of the input. If the input is a 1, then the output is a 0. The input is a 0, then the output is a 1. So let's go back and get to the Explorer so that we can get back to go down to the NOT gate and try to do that. The manual also contains a specification or a page here on the syntax. It looks a lot more difficult than it is. I have mostly explained everything that you need to know with regard to the syntax. The only thing I haven't discussed in the syntax is the use of buses instead of single wires. It also has a section on sequential logic, just simply to say that things don't happen immediately within an electrical component. It takes time for things to happen and flow through things. So you have to be aware of that when you go, and most of the time it's not going to make any difference, but every now and then it does, and you have to be aware that that is true. And we'll probably see that in some of the tests later on, but when we do, we'll discuss that. The only type of component that is not dependent upon the clock is a memory circuit, and where a memory is dependent upon something that happened in the past, and so the rules for that are a little bit different. Notation systems talks about binary and hexadecimal notation. I'm going to skip that in this video for the sake of time, but we're going to come back to binary and hexadecimal notation later. I think I'll give have a video just on how to do binary and hexadecimal arithmetic and so on. It may not be as hard as some people think. All right, so here is our task. The first task is to create a NOT gate. The NOT gate has an input and an output. If the input is 1, the output is 0, and vice versa. Therefore, the NOT gate simply negates its output. Like any other input, NOT gates can be built by using NAND gates. Check out the NAND specification. To get the NAND specification, we could go down and look at the NAND specification, but we'll worry about that later. The interface specification for the NOT gate is inputs in and outputs out. It has one input, one output. They're labeled in and out. The graphical representation of the NOT gate is in. Then the NOT gate there doesn't tell you how to build it, but just shows you that black box is there, and then the out. And the truth table for the NOT gate is if in is 0, out is 1. If in is 1, out is 0. Pretty simple. Now let's tab over to the design, and we've got a pretty simple design here. And the first thing we have to do is specify the parts, and let's specify my NAND is equal to, let's see, is this how to do it? I don't remember. Let's go back to tutorial 1 to well, you know what is really kind of aggravating in this interface is that there's no mouse. And you have to do everything by keyboard on this. It's kind of like the old days. I think my NAND is just, I think the way to do this is NAND. Let's see if it'll let us do that. All right. And now we have to wire them up. We've got parts, we've got NAND, and we've got the my NAND, and we've got the inputs and outputs. Let's see if we can do this. The first thing I'm going to do, and this I haven't told you about yet, but we're going to send a 1 to my NAND. In, and I don't know if that's the way to do it, but let's see. Then we're going to send the in from the NOT gate to my NAND dot in 2, and then my NAND dot out to out. And we hit Control Enter to see if everything works. Failed. Okay. Part my NAND has the wrong syntax. Okay, so that's what I was afraid of. Let's go back up and see if we can't correct the syntax. Is that the right syntax? Let's try it. No. Let's go back. Let's go back here then, and to see what the syntax is, I need a reminder. So we hit Escape. Go back up tutorials 2. Enter, tab, and my NAND, and there's nothing between them. There we go. And we got N1, N2, and out for the NAND syntax. So we'll go back, come back to NOT, hit Enter to go in there, and tab, and I was making things too hard. Here we go. Verification passed. Total NAND count 1. The inputs and outputs are as they are supposed to be, and we have successfully completed the NOT gate in our program. So let's click OK. And now we've got a new task unlocked, and I unlocked a new task. The next task they want me to complete is the AND gate. I'm going to click OK, and it's already put me in the NAND, on the NAND gate, and I could just press Enter at this time and go right on into the program. But I think that's enough for our first video on this piece of software. Let's exit the program real quick and go take a look at the Steam page for this program and see where it is here. And the name of this is MHRD. There we go, MHRD. And we'll go to the store page. You see currently the cost of the program, very reasonable, and get more information about what the application, design of the application, what it's all about. So if you haven't, if you like this kind of game, then I encourage you to take a look at it and come back and watch the next video. We're going to do the next few parts in the next video, and I hope to see you there. Thanks again for watching my videos.